Okay, in this video I'm going to cover Bayes rule. So let's talk about Bayes rule. Let's as always, let's again begin with an example so we can understand what's going on better. Let's suppose that you have cancer patients and you want to know for these cancer patients who's a cancer patient and who's not. So you decide to conduct kind of a medical test. And in this medical test, you discover that 90% of the people with cancer get a positive result, and 10% of the, or let's say 8% of the people without cancer also get a positive result. And let's say that the probability that you have cancer in general is 1%. So what we are going to do is we want to know what's the probability that you have cancer if you actually tested positive. So it's not quite intuitive. Bayes rule can be counterintuitive sometimes because you might just think that it's this 90%, but it's really not. So there's a rule for this, which is that the probability that x given y is equal to the probability of y given x times the probability of x divided by the probability of y. This is Bayes rule. And here I'm not going to try to prove Bayes rule to you, but you can find its proof online somewhere. But let's go ahead and apply this Bayes rule here. So we want to know what's the probability that you have cancer given that you tested positive. So x is going to be the probability that you have. So P of x is this guy right here, probability that you have cancer, and you don't know if you tested positive or not. So let's go ahead and call this P of x. What is Py given x? So this is the that you test positive if you have cancer. So this is your 90% probability. This is your 1% probability. And this one here is just the probability that you test positive in either case. So if you have cancer, you'll test positive 90% of the time. And if you don't have cancer, you'll test positive 8% of the time. So let's break this P of y up a little bit. So P of y, the probability that you have cancer to begin with is just 1%. And that means the probability that you don't have cancer is the other 99%. Of this 1%, you're going to test. So if you have cancer, you're going to live 90% of the time, which means that this is actually the 1% or 0.01 times the 90% plus the 99% of the time where you're going to test positive, which is 8%. So the probability of y can be computed like this. And Now that you know this is zero point 0.9, this is 0.01, you have an expression for the denominator as well. You can go ahead and calculate the probability x given y, which is going to be the probability of having cancer given you test positive. So if you compute this, let me go ahead and quickly I'm going to quickly go ahead and compute this. So we have 0.9 times 0.01 divided by 0.01 times 0.9 plus 0.99 times 0.08, and this gives us a probability of, so this gives us P of x given y is equal to 0.10, which is about 0.1% or 10%. So the probability that you have cancer if you test positive in this situation is only 10%.